Good morning, students. Yesterday we have seen the various types of the coefficient of correlationship. Today we are going to continue this topic. So now you know the different types. Now we have to solve by means of examples. So how to find out the relationship between one variables with the other variables. So today we are going to solve it by means of the formula. So the direct method we are going to solve it. One example, but before that we must know the formula. So if x and y are the two variables having their mean as, first we have to find out the mean, that is x bar and the y bar respectively. So the formula for the direct method is coefficient of correlationship, that is R, of x, y. The variables which you have taken should be in the bracket. That is equals to summation of dx dy divided by square root of summation of dx square into summation of dy square. So this is the formula for the direct method, how to calculate the coefficient of correlationship. Where dx, what is dx? Where dx is equal to x minus x bar and dy is equal to y minus y bar. So if you are asked to find out dx square, then this will be equals to square. So this is dx square. And if you are asked to find out dy square, so by squaring this term, that is y minus y bar will be the dy square. So here, how to find out the coefficient of correlationship, that is R of xy is equal to summation of dx into dy divided by square root of summation of dx square into dy square. Now coming up to the working procedure. So we are given two variables, that is one variable is the x variable and another is the y variable. So we have to denote one series as x variable and the other series as y variable. Next step is that we have to calculate the x bar and the y bar, mean of the x and y series. So you are given two variables, x and the y variables. First we have to find out the x bar, that is mean of the one series x series and the mean of the y series. And the third step we have to take the deviation of observation. We have to take the deviation of the observation in x series from the mean. So from the mean we have to find out the deviation of x series by means of, and written as sigma x is equal to x minus x bar. That will be the deviation. So we have to find out the deviation. The first step is we have to first denote the two series, x and y series. Second is we have to find out the mean. Third thing is that we have to take the deviation from the mean of x and y series both. Next is that we have to find the deviation. We have to find the deviation for the y series also, as the deviation that can be written as dy is equal to y minus y bar. Here dy dx is equal to x minus x bar. So here we have taken out the deviation of the y series. Then we have to square this deviation because we need dx square. That's why we have to square this deviation. Here also we have to square the deviation. Now coming up to the contingency table, how to plot the table. So in order to plot a table, you have to plot a table and you have to write the various variables. So the first column will be the serial number. So here we have to write down 1, 2, 3, 4. How many data will be there can be represented over the here. So here serial number 1, 2, 3, 4, etc. will be placed over here. Next is the X series. So this will be the X series. Next will be the deviation from the mean. So it can be denoted by means of the dx. So dx, how it can be calculated? That is deviation from the mean. Means what? X minus x bar. So it can be calculated by means of first calculating the mean and then we have to subtract the series of x per first observation and from the deviation. That is x minus x bar. What is x? This is the first observation and x bar is the mean. So we will get the dx. Then we have to square this dx because we need dx square. So this is nothing but the dx square. Dx square. So we have to find out the dx square. Similarly, for the y variables, we have to put all the y variables over here. That is 1, 2. So, the variables which is given over here. So the variable should be kept, y variable will be placed somewhere here. Then we have to find out the dy. How to find out the dy? The deviation from the y, that is a y minus y bar. So y bar is the mean of the y variables. So whatever the variables is given there, we have to first add all these variables. You subtracted the number of observation, then we will get the mean. So we have to find out the dy by means of y minus y bar. Next we have to square. We have to square this deviation by means of dy square can be written as, and next will be the dx into dy. So this is the dx and this will be the, so we have to multiply dx into dy. So this is the dx and this is the dy. Now first, for all these things we have to add all the dx. So here there will be the summation of the dx and this will be the summation of dx square. Similarly, this will be the summation of dy and this is the summation of dy square. And this is the summation of dx into dy. Now we have to put inside the formula. We know the formula. The formula is summation of dx. So we know the formula, that is coefficient of correlation is equal to summation of dx into dy divided by square root of summation of dx square into dy square. It can be also written as summation of dx into summation of dx into y divided by square root of summation of x square into y square. Next we are going to solve this problem. The formula, you know the formula. Now we have to put inside the formula and we have to solve how one variable is related to the another variable. So the given example, that is find the coefficient correlation between the height of the father and the son for the following data. So here two variables are given there. First variable, consider this is as a x variable and this is as a y variable. So what is x variable? Height of the father. And what is the y variable? Height of the son. So is there any relationship between height of the father and the height of son is there. We are going to find out by means of the formula. So first we are asked to find out the mean. So we have to find out the mean. Therefore, the x variables, what are the x variables? That is 64 plus 65 plus 66 plus 67 plus still 70. So here we did the same thing, 64 plus 65 plus till 70. So we have added all the observation of the x variable and then we have to divide it by the number of observation. So what is the number of observation? 1, 2, 3, 4, 5, 6, 7. So here the number of observation is 7. So we are going to add all these variables of x and then we have to divide it by 7. So altogether it comes around 469. 469 divided by 7 will gives you the 67. So what is 67? It's nothing but the x bar. Similarly, we have to find out the y bar. So here also we have to do the same thing. We have to find out the y bar of the y variables. So here we have to add all this together, that is 67 plus 66 plus 72 So here we have to add all these variables as 66 plus 67 till 72 divided by the number of the y observation. The number of our y observation again 7. So here we have to divide all together by 7. It comes around 483 divided by 7, that is equal to 69. So the x mean, x bar, it comes about 67 for the x variable and y bar it comes around 69 for the y variables. So now we have to put in the table. So the first column will be the x variable, here y variable. We have not taken the serial number. If you want, you can take the serial number as the first column. So here we have written the x variable and similarly we have to find out the deviations, that is x minus x bar. So here this is dx can be calculated as x minus x bar. So x bar it comes around 67. So x bar, that is 67. So here x minus x bar, that is 64 minus 67, it comes around minus 3. Similarly, we have to do it for the next one, that is 65 minus 67. How much you will get? Minus 2. Similarly, you have to do it for rest of them. And here also you have to here in this case, here we have to just square it. So if it is minus 3, the squaring of whole together will gives you the 9. That should be positive 9. Similarly, we have to go for the y variables. First we have to write down all the y variables. So the y variables, that is 66, 67, 68, 69, 70, 71 and 72. So we know the y bar is almost 69. So we have to subtract from the observation, that is 66 minus 69. How much you will get? 66 minus 69, you will get almost minus 3. Similarly, next variable, that is 67. So 67 minus 69, that is equal to minus 2. So here you will get minus 2. So here you will get minus 3. Here you will get minus 1, 0, etc., etc. So now we have to make it a square. That will be the dy square. That is equals to 9. This is equal to 4. This is equal to 1. Similarly, you will get the summation of dy square. If you add all this together, then you will get the summation of dy square. This will be Now here we have to multiply dx with the dy. What is dx? Dx is somewhat this one. That is equal to, so the dx will be minus 3, and what is dy? Dy is minus 3. So we have to multiply both this minus 3 with the minus 3. So you will get minus 3 into minus 3, that is equals to 9, positive 9. Similarly, we have to multiply dx of the x variable, that is minus 2 into minus 2, that will comes around 4. So in this way we have to sum all this dx into dy, that is equal to, that is summation of dx into dy. Similarly, we have to do the summation of dx, summation of dx square. Y mean is given over here. Next is summation of the dy square, summation of dy square, and then the summation of dx into dy. So I have already suggested you, given you how to calculate the coefficient of correlationship. Now you have to put inside the formula and calculate the result. So I expect you will do rest of them. So tomorrow we are going to continue with the same topic with one more example. Thank you for watching.